Okay, here we are, number 6. Kind of a unique problem here. We've got a circle inside this right triangle, and we're told that the sides of triangle ABC are tangent to circle G at D, E, and F. AC is 15, BC is 8, AB is 17. So let's mark up our figure. So oftentimes when I'm working with students, they can't see the solution because they haven't got their figure marked up. So there are relationships that are escaping them because they don't get the visual cues that marking up the figure provides for them. So make sure you're doing that. And every time you get a new piece of information, then add that to your figure. That way you'll see the relationships far more often if you do it that way. So here's what we've got. We've got these 3 external points. Here's A, and we're told that and these are the vertices of the right triangle also, so that they're tangent to the circle. So what we know about these tangent lines from the external point is that they're equal to each other if they're coming from the same point. So we know AF equals AE. Alright? Then we also know, here's B, that BF equals BD because of what we know about tangent, lines that are tangent to a circle from an external point. Then we also know from point C here that CD equals CE. Right? Right, so that's information that we've got to start with here. What kind of triangle is triangle ABC? Well, what they're getting at is this. What do we have here? 64 plus 225 equals 289. And it does. So it's a right triangle. It is a right triangle by the Pythagorean converse theorem. I'm going to abbreviate because I want to save some room for the work I'm going to have to do here. Alright. What kind of quadrilateral is CD or GDCE? So we drew EG and DG. Those are radius of the circle. So that's R. Alright, and this is a square. Now they want us to write an equation and solve it for R. Alright. Now this is where people get lost. Most times people can follow all the way through here. But here's where people get lost because you need to take the time to figure out how to describe these. AF and AE are equal to each other. And what do they equal? Well, they equal, as we can see from here, AC is 15, and this is R. So AE equals 15 minus R, and so does AF equal 15 minus R. Same thing up here, BF and BD, they equal, here we have this whole distance of 8 minus R, so 8 minus R, and then CD and EC or CE are just plain R. So there we have these values that we need. We also know that the two that we drew EG and DG are also R. Alright, so now we're supposed to write an equation and solve it for R, and you might be wondering how are we going to get this? Well, the way we do it, again by marking up our figure here. Since these two are tangent, BD is tangent to BF, they're both from the same external point, they're equal to each other. So if BD is 8 minus R, so is BF 8 minus R. So what have we got here? What have we really got? We've got this. We've got two different ways to express this value here. We'll just use the hypotenuse for an instance here. So we've got 15 minus R plus 8 minus R, that equals 17. And that's the equation that's going to help us figure out what R equals. 15 minus R plus 8 minus R equals 17. So we had to get two different ways to express values that were equal to each other, and that's what we've done here. Alright, so that's an equation. 15 minus R plus 8 minus R equals 17. Now we're going to solve it. So we can combine our like terms. 15 and 8 is 23. Minus R plus minus R is minus 2R equals 17. Now we just solve this. Okay, so minus 23. And we have negative 2R equals negative 6 divided by negative 2. And we found that R equals 3. R equals 3. Alright, so what's the key for this? It's right here. It's figuring out two different ways to describe the same length and putting them equal to each other and solving it. And the way we do that is by knowing about what this means, that we have these tangent lines from external points here. We can determine a way to describe them. 8 minus R, 15 minus R. If we add those two together, we get 17. So that's the equation we end up solving. Alright, that should hold you on this one. See you on the next one.